Alright, so I'm going to go one direction first ways. So assume that both n and n plus 2 are primes. So by Wilson's theorem, we have n minus 1 factorial is equivalent to negative 1 mod n. Or in other words, n divides into n minus 1 factorial plus 1. So if you look at this expression, you've got n divides into the first term, so n divides into n minus 1 factorial plus 1. And then we have plus n, so n obviously divides into that. So n divides into the entire expression. That's not the hard part. We have to consider n plus 2. So there's a trick here. Take the original expression again and multiply by n. So you've got 4n times n minus 1 factorial plus 4n plus n squared. Alright, so consider this expression in mod n plus 2 world. Alright, so now this becomes, you've got 4 times n factorial plus 4n plus n squared in mod n plus 2 world, but I won't write that down, just assume we're in that world. So now if we consider n plus 2, if you take n plus 2, subtract 2 from it, so you get n factorial. That's equivalent to 1 mod n plus 2. Or in other words, you've got n factorial is equal to 1 plus k n plus 2. Now, in this universe, you have n squared plus 2n is equivalent to 0, which is the same as saying that you've got n squared is equal to minus 2n. Now, take this expression here and plug in this and plug in this. That gives me 4 times 1 plus k n plus 2 plus 4n, and the n squared gets replaced with minus 2n. So that becomes equivalent to 4 plus 4k n plus 1, n plus 2, sorry, plus 2n, so plus 2n. Now factor out the n plus 2. We're going to get n plus 2 times 4k plus 2. So we get this expression, which tells me that n plus 2 divides the original expression. And so we have n plus 2 and we have n dividing the original expression. That tells me that this expression is equivalent to 0. And we're done in one direction.